Hey there, class. Mr. Plusky here. Hope you're having a good day so far. We're continuing with Chapter 9, which is about transformations. Today we're talking about matrices. Say matrices. Matrices are the plural of matrix. Say matrix. Plural of matrix. Okay? So matrices are kind of like, I guess, just trying to think of a good word. Just an organization of numbers. It's kind of a table of numbers and we can kind of use those to I think they're very useful actually. I don't know if you remember back in Algebra 1 with solving systems of equations using substitution or elimination where you do cancel or do stuff, but there's actually a way to use matrices to make that really an easy process. However, we don't really seem to it's not a big point of learning in math education right now, which is a bummer for me. But yeah, we are going to use it today for can be useful for transformations as well. Okay, so no warm up today. Let's get into this. A matrix is a rectangular arrangement of numbers in rows and columns. And what? Rows and columns. Okay. An element is each number in the matrix. Each what? Each number in the matrix. Dimensions, the number of rows by columns. Of what? Rows by columns. Okay. And in parentheses, we have rows by columns. Okay. And so, for example, if you have a matrix that's 3 by 2, the first number, like we said, is rows, and the second number is columns. Okay? And rows are going to be, you probably know, but they're horizontal, and columns are vertical. Okay? All right. So, example 1, we're going to write a matrix for a point or polygon. Okay? What we want to do, we want to talk about point A here. Let's use a different color here. Here's point A. What are the coordinates of point A? Well, the coordinates of point A should be -3, 0. Okay? And so when we're writing a matrix for point A, we're going to do these kind of square brackets like this. Okay? Well, let's make that better. You can't see that too well. We'll do square brackets. Okay? We're going to put A on top, and we're going to take the coordinates, and we're going to go kind of in a vertical fashion. It's kind of weird, but that's kind of how we do it, okay? So we're going to put the x coordinate on top. What's the x coordinate here? Remember, this is x and y, right? So what's going to go on top? X. We have -3 is going to go on top, and 0 is going to go on the bottom. So we put the x on top and the y on the bottom, okay? And that's how you make a matrix using coordinates for a point. Okay, sounds good. All right, now we're gonna make it a little bit more complicated, but not super complicated. We're gonna do the same thing, but we're gonna talk about quadrilateral A, B, C, D now for all the points. Why don't you guys, so we know the coordinates for A were -3, 0. Why don't you guys see if you can find B, C, and D? Okay, so we want B, C, and just find the coordinates here. Find all the coordinates for these. Go ahead, real quick. All right, B should be 0, 3. C should be 2, 1. And D should be -1, -1. Okay? So we're going to do a similar thing. We're just going to make kind of a wider bracket now, okay? Let's see here. And also the letter for the matrix is going to be above. So we had A was above here, okay? Here's B, C, and D, and we close bracket, okay? All right. Cool. So like we did for A, we had -3, 0, x goes on top, y goes on the bottom. Why don't you guys see if you can fill out the rest of this really quick? Go ahead. All right, B was 0, 3, so x goes on top, y goes on the bottom. C should be 2, 1. 2, 1 goes like this. And D goes -1, -1. And that's it. So we're basically just finding a new way to kind of represent, points in kind of a neat. I kind of like this. I think matrices are pretty neat and organized and cool in general. Okay. All right, we have a checkpoint. It's a very similar thing. We have a triangle RST with these vertices, and why don't you guys see if you can do that really quick? Go ahead. All right, so RST. So we're gonna do this. We have R, S, and T. Okay. So what you should have gotten for this, R negative 5 was X, negative 4 was Y. For S, we had negative 1, 2 was Y. For T was 3, and 1 was Y. Cool, and there we go. All right, sounds good. Okay, now we're going to talk about what are called matrix operations. So we can either we can add or subtract matrices, we can multiply matrices. There's lots of different things we can do here, okay? And so we're going to talk about adding and subtracting matrices, okay? Now, the trick, basically what we're going to do is we're going to add every number that's in every matching position, okay? But one thing it says in here is you can only add or subtract matrices if they're the same size, okay? So the same size, all right? So for example, we have for A here, we have this matrix. What's the dimensions of this matrix right here on the left? This is a 2 by 2, okay? So in order to add these, we need the other one to also be a 2 by 2 matrix. We have 2 rows and 2 columns. What do you guys think about the second one? It's also a 2 by 2, right? So we can add these, which is good, okay? All right, so we're gonna show our work the first time here, and then we'll kind of, well, I don't know, we'll show our work. All right, well, let's do this. So let's make our thing here, okay? We're gonna make a new matrix, okay? So we're gonna this is addition, okay? So we're gonna add 4. Which one's in the same position, top left, in the other matrix? 1. So in the top left, we're gonna do 4 plus 1. And then we have over here we have negative 2 matches with what? We have negative 2 plus 2. Okay, so if you can figure out the other 2 really quick, go ahead. All right, then we have 2 plus 5 in the lower left, and we have negative 3 plus negative 6. Okay, and then we're going to simplify this and write an actual thing here. 4 plus 1 in the top left is going to be 5. Negative 2 plus 2 is going to be 0. 2 plus 5 is going to be 7. And negative 3 plus negative 6 is negative 9. Okay, and this is going to be your answer here. If you want to skip this part right here by writing them all out, if that confuses you, or just it's kind of you don't need to do that, you can just do the math in your head and just do this. That's totally fine. I don't really need to see... I don't know. It's pretty basic. I don't need to see that's intermediate stuff if you don't want to. Yeah. It'd be good to show your work, I guess, but I'm not going to enforce that because it's pretty basic math. Okay? All right. B. First thing we need to check is the dimensions of this here. So what do we have here? How many rows, how many columns in the first one? This is a 2 by 3. How about the second one? Also a 2 by 3. Okay? What's the difference between this one and the second one? I mean, there's different sizes, but also this is subtraction, right? So we're going to need to be a little bit careful with this, and you'll see why, okay? So let's go ahead and do this. So we're going to subtract everything in the matching parts here, okay? Matching side, or matching positions. So we have top left, top left. So we have the top left is 7 minus 3, okay? Now, the middle one's a little bit tricky. We have 4 minus negative 6, okay? So we got to be careful with that. It's the only thing that we can kind of goof up here. And at the top right, we have 5 minus 5. Then bottom left, we have 1 minus 0. We have negative 2 minus 7. And we have 8 minus 1. Okay? So yeah, if you make any mistakes on your homework or stuff, I would encourage you to write out this middle stuff here. Okay, then let's just combine these. What's 7 minus 3? That's 4. 4 minus a negative, chop, chop. 4 plus 6 is going to be 10. 5 minus 5 is going to be 0. 1 minus 0 is going to be 1. Negative 2 minus 7 is negative 9. 8 minus 1 is 7. All right, and that's our answer. Okay, so that last step is okay if you can do that in your head. Just be aware that if you're making mistakes, it might be good to write out what's happening. Okay? And make sure, for example, if we had, so let me show you an example that wouldn't work. What if I had 2, 4, negative 1, and 5? And I had plus 1, 3, 7. Can I add these or no? I can't, right? Because this is a 2 by 2, and this is a 1 by 3, right? There's one row and 3 columns. So this one would not work, okay? That's what I mean by it not working, okay? All right, sounds good. Let's talk about, basically using a translation now with matrices, okay? So we have this matrix here, represents a triangle. We're trying to find the image matrix that represents a translation of 4 units left and 1 unit down, okay? Well, 4 units left, is that X or Y? That's X, right? And what are we going to do to the X when let's use a different color here. What we're going to do to the X we're going to add or subtract to the x if we're going left. It's going to be x minus 4. And what about 1 unit down? Is that going to be plus 1 or minus 1 to the y? It's going to be y minus 1 here, okay? So we're going to do a couple things here, okay? We're going to write the polygon, okay, the polygon matrix. Need some more space here. Polygon matrix, okay, plus the translation matrix. We're going to add them, and basically that's going to go ahead and that's going to do our thing here. And that's going to equal the image, okay? All right, so what's the polygon here? We talked about that. Triangle ABC, right, was 2, -3. We have 3, 2. Those are pretty bad. 3, 2. And we have 4, 0. Yes, we're adding that plus, what's the translation matrix? What are we going to do to each x value? We're going to subtract 4 from all the x's, right? Well, is that going to be the top or bottom? Well, x is on top, so we're going to add -4 to the top. And what are we going to do to the bottom? We're going to subtract 1 from the bottom, okay? So it's basically just doing a translation like we've been doing in the same way here, okay? All right, so what's 2 plus -4? That's going to be -2. Right, we did this plus this. These are 2 by 3s, right? So we can add these. All right. How about the middle one? 3 plus -4 is -1. Why don't you guys see if we can finish this off here? Go ahead. All right, then we have 4 plus -4 is going to be 0. Bottom left, -3 plus -1 is -4. 2 plus -1 is 1. And 0 plus -1 is -1. Okay, and that's going to be the image. All right, so basically it's the same thing as we've been doing, it's just a different representation of it, okay? All right, we have some checkpoints here. Why don't you guys go ahead and do the checkpoints, see how you do. All right, let's go through these. I'm just gonna write the answer here because we should know how to do this. So we have checkpoint would be 3 minus 9 in the top left would be -6. 3 minus 7 in the top, -5 minus 7 would be -12 in the top right. 8 minus -3, remember, would be +3. It would be 8 plus 3 is 11. And -4 minus 1 is going to be -5. Okay. There's our answer. How about this one over here? Oh, number 3. Can we add these? This is we should have checked over here. This is a 2 by 2 and a 2 by 2, so we can add those. How about over here? This is a 2 by 2 and a 2 by 3. 2 rows, 3 columns. We can't add these. So no matrices, not same dimensions. Okay? All right. Okay, and then we have similar thing we did before. We have this triangle, and we're trying to do a translation. 3 units right, it's going to be x plus 3. And 2 units up is going to be y plus 2. So we're going to have the polygon. Polygon is going to be, we have -3, -1, -1, 3, 0, 0, plus the translation matrix. Okay, we're adding 3 to all the x's on top, and we're adding 2 to the y's on the bottom. It's going to equal the image matrix, which is going to be, in this case, it should be -3 plus 3 is going to be 0, -1 plus 3 is 2, 3 plus 0 is 3. On the bottom, -1 plus 2 is going to be, let's see here, is going to be 1. 3 plus 2 is going to be 5. And 0 plus 2 is going to be 2. And this should be the actual answer right here, okay? All right, and that should be it. Okay, thanks for watching. Have a great day, and we'll talk soon.